So I got to start off with saying I'm a little sick. So if my voice cracks, I'm actually surprised my voice is actually working right now, because this morning I didn't think I was going to be able to do this. So I'm going to drink a lot of water, and I'm on Sudafed and cough drops and everything else, right? So I might say something crazy, but thanks for bearing with me on this. Well, thanks a lot for coming. This is kind of a fancy title. I'll talk about that in a minute. It's Operationalize Data Science for Advanced Decision Support. I think if I were to rename this, I'd probably call it the Data Science Lifecycle, right? More than anything, right? But well, I'll introduce myself in a minute, but I've actually done this session here before. Maybe the first time was in about 2014 or 15, and I've probably done it about 3 times since. So maybe the last 6 years I've done it 3 or 4 times. And I've changed the name to kind of keep up with the times, right? But I think last year, maybe the first time I did it, I called it Operationalizing Predictive Models or Predictive Analytics, right? Or Pervasive Predictive Analytics, and I've kind of changed the title over the years. And then this is the first year I'm actually doing it using Azure as a way to do this, whereas before it was a concept, more of a concept of how to do it. So I'll talk about that a little bit more in a minute. You guys seen this, silence your cell phones, everything about pass. So get involved if you want to, and it's a great organization. So I'm Carlos Bossy. I'm one of the partners in a company called DataLear out of Denver. And we do basically, I guess, BI, analytics, data science, data warehousing, big data, that kind of thing. So 15 years ago, I started consulting. And up to that point, I'd really been in the software engineer space. And for about 15 years, I've been a software engineer, mostly for a couple of big software companies, or a couple of software companies. And then did a startup for a little while after that, for about 4 years. And then when I left the startup, I decided, well, the future's data. So I'm not going to be in a software engineer anymore. I'm going to be like a data expert, right? That's how I kind of sold myself. So back then, about 15 years ago, it was really about building a lot of data warehouses and dashboards and that kind of thing. And it's all kind of grown up from them. But I was always having a math and statistics background, I always pushed the data science side of it to clients, even back then, even though we didn't call it data science, right? I tell people I did data science before we called it data science, right? But had a difficult time getting traction sometimes. Did a few really cool projects, but even like today, right? A lot of data science projects fail or aren't succeeding. We look at clients that think everybody else is doing it except them, or they'd like to do it, but they can't get yesterday's sales report out, right? So there's a lot of struggles with it, even though obviously it's gotten a lot of hype in the last few years. Is anybody here a data scientist? A few people here? Okay. And you're actually like real data scientists. You spend all day delivering predictive models to people, right? Is what you do? No? Yeah. So that's really what I'm going to talk about here. In fact, that's one of the things I kind of want to hear about, is some of the experiences here about how it works or doesn't work in your organizations. I think it teaches people a lot. It also lets me not talk all the time right now, which I kind of need to. But coming from a software background, to me, the data science lifecycle isn't that different, right, from the software development lifecycle. But it's kind of grown up in a very different way. A lot of data scientists weren't software engineers or didn't have software backgrounds, didn't come from that space, used tools that were very different, right? Used tools that weren't maybe ready for stuff like this. So anyways, I'll talk a little bit about that. A lot of what I talk about, I'll show you the tools and how Azure ML, I think, is growing up to be able to support some of what I talk about. But a lot of what I talk about will still be somewhat conceptual, right? It's an idea that you need to put in place, just like source control, right? We all need to do source control, but I'm not going to talk about a particular tool on which tool to do source control with. You know, some of what's in Azure Machine Learning services right now will help us with the data science lifecycle, and then I think then I'll talk about where I think it needs to go, you know, and that sort of thing. Don't forget about session evaluations. I guess they got to be submitted by tomorrow, or no, next week. Actually, next week. I didn't even realize that. Next week at 5 p.m. Friday. So now that you can do them online, that's the way to do them. So what is operationalizing data science? So to me, it's about how do we deploy our work as a data scientist into production, right? So years ago, a statistician, maybe where a data scientist might have come from 20 years ago, maybe did a lot of work, spent a month working on next year's financial numbers, and gave the CFO or the CEO a report and said, hey, we're going to increase sales next year 3.8%. That's my prediction. That's our forecast. And we need to base everything around that. Today, the data scientist is much more integrated into the organization, or should be, right? Today, a data scientist, what you produce needs to be used by everybody else. Not the CEO, not the CFO, but developers, analysts, users, customer service agents. You need to put it in the hands of everybody to make it really powerful. The companies that are actually doing it well, that's what they're doing. They're putting it in everybody's hands. So how do you put it into production? How do you make it accessible? And then how do you monitor its performance? You know, how do you make sure it's working, doing what you want it to do? You know, business conditions change over time. Data changes over time. Assumptions change, right? If I built a model that predicts something about a certain customer, is that still valid 2 years from now? You know, is that still valid next month, right? So that's really a lot about what this session is about. I'm probably not going to go down this agenda in order, but essentially I'm going to talk about a methodology, which I'm already kind of talking about. I'm going to do a little bit of predictive analytics and use machine learning, right? Just to kind of, I'm not really going to show how to do machine learning because that's not really the purpose of this session. I can talk a little bit about some real-world approaches and solutions, like experiences I've had. Like I said, I put some models into production 15 years ago when I first started consulting, and I saw the life cycle of those over time and what happens and how things work, you know, and that sort of thing. Then how to operationalize, you know, what it means to deploy, monitor, and tune, what the ML life cycle is from end to end, and how to get to what we would call ML ops, or like a DevOps for machine learning, right? And I think that last point is really just kind of a little bit of, this session won't show that, but it'll help you get there, right? Kind of show you that that's maybe the next step as to where you need to go. So for those who are new to data science, I think there's been so much about data science these days out in public that maybe people now know what data science is, because this is a slide I've probably had in here now for 5 years or 5 or 6 years, right? But you know, why do I do data science? Well, primarily I think to learn from existing data, learn from data that we have, learn patterns, learn things that a human can't see, right? Essentially, find quote unquote hidden patterns or difficult to spot patterns, you know, that kind of thing. So I want to be able to also predict in a repeatable manner. And what I mean, you know, is a customer walks in my door, make a prediction about that customer. When I mean a prediction, it doesn't maybe necessarily mean something about the future. It might mean something that I don't know about them, right? Like that customer who just walked in the door, that's a premium customer, even though we've never seen them before, right? Why do we know that? Because of some data we've collected that can predict that customer will be a premium customer. And I may treat that customer differently if they're not a premium customer. So be able to do that over and over again. And everybody who walks in the door, make a prediction about them. You know, let's see, are they a premium customer? Are they not? How do I deal with them? I want to make my apps smarter, my reports smarter. When I produce that report in the morning, I can tell you everything I've done with my customers over the last quarter. But what if I added to that report, hey, these are the customers that I think are going to leave, who we're going to lose. These are the customers who are going to increase their purchasing by 50%, right? So be able to add that kind of intelligence to my reports and my apps. And then again, find any patterns and correlations that humans don't see. Now, I always tell the story, I've been in this business a long time. I mean, it's only software engineering or this is the only work I've ever done. So when I was 23 years old, we would have a big marketing database of about 60,000 customers. And I kind of look back on it and I think now with the scale of what we have today, back then it felt like some of our people knew every customer in that database, right? Like they knew all 60,000, or in a department, they kind of were familiar with all of them. And today, of course, you can't do that. You know, you've got so much data, so much going on, you can't know everything in there. So operationalizing then, what do we mean by operationalizing? Well, it's really bringing data science development and converging it with other data and software engineering activities. With data movement and transformation, hugely important, right, in what we do today. Deployment monitoring, performance analysis. So operationalizing it is making sure, again, what you're doing as a data scientist is integrated with everything else going on. So one of the things we talk about sometimes, I guess, is data science as a service, and this is kind of heading towards that as well. If I am able to produce models that other people can tap into in my organization, and without really knowing what's underlying it, right? How it works, what's the quote unquote, I always hate the word when people say magic, but what's the magic underneath it, right? You know, and I don't like that word because we all know it's not magic. We all know, you know, it's one line of code after another, after another, after another, right? That makes something happen. But, you know, how do I make it a service to everybody else that makes it available and useful to everybody else? So if you look at it like this simply, like this, this is a function, right? I pass it variable x or multiple variables, right? X of 1, x of 2, x of 3, x of n, and I get back a y, right? And essentially, I have 100 things I know about a customer. I'm going to send you those 100 things. You give me back some information I don't know about a customer, right? That's essentially what I'm trying to do here. And so this is exactly what I'd like. Then I can make a decision, right? If this algorithm is good, I can make a decision about a customer. So for example, if years ago, we would create functions like this just to do simple calculations that we wanted to spread in the organization, right? Somebody create a function that calculates, I don't know, the number of days since day one in our organization, right? Or something like that. You know, things that are kind of commonplace today or easy to do. And then you'd spread this throughout the organization so everybody calculated it the same way. You know, so nobody really knew how it was done under the covers, but that's what it would do. So you can tell this slide's a little old because I've still even got the old Hadoop elephant in there and stuff like that. But essentially this slide is really about, there's all this data in the enterprise, and we need to transform it, acquire it, merge it, put it somewhere. And as a data scientist, this looks like a relational database because I did it so long ago, but it really is kind of maybe more of your data lake, right? I'm gathering all this data that matters to my organization and landing it in a data lake, and now the data scientist can do something. And that's one of the key points about why some of this sometimes doesn't work so well in a production model, because when that customer walks in the door, where is all that data? Those 100 data points I want to know about them, where do I get them so I can make that prediction at that moment in time about that customer? It's a difficult thing to do, right? The data scientist may have acquired it, merged it, brought it together, localized it, done whatever they did, but in real life, in real time, it's not necessarily available to me the way I need it to be, right? So a difficult aspect of it is this data engineering aspect of it that needs to happen for it to work the way we'd like it to work. So before I started doing the Azure, or before this year, the Azure Machine Learning Services side of this diagram is what was my concept about how data science needed to work in an organization. And essentially, what I'll do is zoom in a little bit here. Oops, wrong screen there. I'm not sure I'll be able to do it the way I want to here. Let's see. Yeah, so basically, the same concept here. On the left side, we've got all this data, transactional data, files, Excel files, social media, email data. It all lands in a data lake. It gets transformed into some other place, by the data scientists in this case. They have to transform it to make it work for them. And then they go through this development process, statistical analysis, algorithms being applied to the data. And in the end, they come up with something good, something that says, hey, this is actually predictive of what you want, or it classifies what you're looking for. And then at that point, they would put it in some kind of repository, right, where it's available to people to use. And then the apps or the other production apps and reports can start to use it. They can access that repository and say, okay, now I need to predict something about a customer and put it on a screen so somebody can make a decision, or put it on a phone so somebody can make a decision. So this piece of it is, like I said, somewhat conceptual. I mean, this doesn't really exist. If you develop this, you'd have to develop it. But today, the direction like Azure Machine Learning Services is going, it's kind of trying to do part of this, and I'll show the examples of that and how it's working, and where it kind of handles some of the stuff we have up here. So, yes.
So your statement on making data science a service. So one of the things is, right, if you're don't really know what your data set coming in, then if it's actually going to be a proper fit within your model that you're utilizing. In this type of framework, would you have predefined training sets that could go back to your customers that are utilizing your service?
Yeah, let me see if I understand that. So to me, the data scientists would have well-defined training data sets that.
Customers, if you're doing it as a service,
Yeah.
you're saying, here's this model.
Oh, I'm saying as a service within your organization, right?
Okay.
Not outside your organization.
Sorry,
So, Joe next to you gets to use it as well and has access to all the same data, right? Yeah, I understand. I think so there's a data engineering aspect to this, but the idea behind this was that if I'm classifying customers and I'm saying, for example, I'll show a little example later where I'm predicting a customer's income. Well, am I right or wrong, right? I mean, the model might be great, historically it might have worked right, but how do I know in the future I'm right or wrong? And so when that customer walks in the door and I have to make that prediction, the function comes back and tells me, yep, their income is $68,000 a year, right? And later on, if I have the opportunity to find out what their income is, then I'd be able to say we were good or we weren't good. But if I don't record that output, then I lose the ability to say, are we doing good or not? So a predictive model may have gotten into production and it's working fantastically. For 3 months, it's predicting everybody's income spot on. But how do we know 6 months later it still is, or a year later it still is? Not only that, your conditions change. You as a customer, the next time you walk in the door, you're not the same person, right? You've bought more stuff, you've bought less stuff, you've come in less, you haven't paid me. Your profile changes, and now I'm predicting your income's different, right? So which one of those is right? One time I predicted your income 68,000, another time I predicted it's 43,000, right? So being able to track that and determining whether I'm good or not, and can I go forward with the model without tuning, or do I need to tune it, is a huge aspect of this. I tell this story. I've told this story every year. So I had a company that ran events like this, right, where they would they did it for companies and for conferences and things like that. So they'd have maybe 5,000 to 25,000 people come to any event. So they wanted to know how many people are going to come to our event, right? I mean, that's the most important thing in running an event like this, because if you estimate too high, well, you spent a lot of money that you didn't need to spend, right? You had more space and you didn't use it. You bought more food, you didn't use it. And if you estimate too little, what happens? Well, everybody gets angry, right? You don't have enough food. There's not enough places to sit down, right? Because the rooms aren't big enough, So what they were doing, they'd been doing this for years, for like 15 years, capturing this data and doing what I would call a basic statistical model, right, to determine how many people would show up to an event. So like 90 days, 60 days, 30 days before, they would do some calculations, and they knew it wasn't very good. They knew it could be done a lot better. So, and this was back in 2006 or 7, I think, something like that. So we went in there, we built a model that predicted, using a neural network, actually, if I remember right now. I'd forgotten about how we did that. But we built a model, and said, hey, we can predict. It was doing really well, right? In fact, we put it into production. Their model was off by plus or minus 15%, right? The way they were doing it. They wanted to be within 5%, and plus or minus 5%. We were hitting 3.5%. So plus or minus 3.5%. So they were really happy with it, right? Oh, this is fantastic. We're so much better at being able to plan these things. About once a year, I would talk to them and go, hey, how's everything working up? Things are working fine, right? No problems. One day, 5 years after we put it in production, they called me and they go, we think it stopped working yesterday, right? And I said, so they go, something broke. It's like something's wrong. Well, I told them, conditions changed, right? You changed something, and we made assumptions when we built it. Those assumptions are different now. And that's exactly what had happened. As we collected data, we were building like this daily view of registrations that they were getting to events. And the daily view always assumed that the last day was a full day. Well, they changed when they were acquiring that data during the day to like 3 in the afternoon. So now the last day wasn't a full day anymore, and the model wasn't working, right? It changed everything, right? So we had to rebuild it and refactor it to make it work. So those are the kind of things I talk about, like things like that worked for 5 years, and I'm actually shocked it worked for 5 years. There was another time it didn't work, and they said, well, we had a hurricane, right, or something like that. Couldn't the model predict, change what it's doing based on the hurricane? I said, well, if we had a lot of history about hurricanes and about people registering when there are hurricanes, I would know, right? But we don't have that, right? So you can't adjust or adapt to everything, and then you have to make sure business conditions are the same, right? Because if you don't track it, things will stop working. So, for example, another problem I always talk about is churn, because everybody wants to know churn. When am I going to lose a customer, right? We're all customers of cell phone companies, cable companies, and we all go to the competitor. We bought the iPhone, then we bought the Samsung phone or something else, right? They lose us. And so the main thing companies like that want to know is, who am I going to lose, right? I know I'm going to lose, 0.5% of my people or 1% of my people every month, but who am I losing, and can I keep some of them? So if you think about how hard that problem is, I mean, they obviously have a lot of data about you, right? They know how you use your phone, how often you use it, do you pay your bill on time, all that. But when I ask the question, am I going to lose you, how do I frame that? Am I going to lose you in 60 days, in 30 days, in 90 days? How likely is it that I'll lose you, right? I'm probably likely to lose everybody to some extent, right? Or further down the line, I'm likely to lose somebody. And then when do I make that prediction? Do I make it now, a month from now, every month, every day? Do conditions change on a daily basis that now I can recognize I'm going to lose you when before I didn't, right? So those kind of problems and how to deal with them are essentially what this session is about. So for example, questions you might ask about a customer. And you can build this profile of a customer that's huge, right? Are they an Apple customer? Do they pay their bill on time? Are they a fan of professional baseball or soccer? Is their average purchase increasing or decreasing? Video games, political party, all these things could matter for what you're trying to classify them as, or how you're trying to predict. And again, where do you get this data? If that customer walked into the door today, do I have this data all together and ready to feed into my model to give me an output? It's a hard thing to do. And then there's time variance involved, right? If I'm making a prediction once a month about a customer, and let's say I'm predicting whether I'm going to lose them on June 1st, I said no. When do I check to see if I lose them? Well, do I check December 1st and say, I didn't lose them by December 1st, so my prediction was good, right? But I don't know that till later, and I have to, when I made the prediction in June, I have to then later on in December go see if I was correct, right? And see if it's working. And let's say in September I predict that I will lose them, and I check March 1st and I don't. But let's say I lose them on April 1st, right? So was that a good prediction or a bad prediction? Is that working or not working, right? Well, I think business-wise you need to understand what your goals are there. But the point is here about tracking everything. Every time I predict something, track it, and then always compare it against what really happened to make sure it's good. another example, just to kind of bring that point home, is people have a hard time with hiring, right? I'm going to hire somebody, and there's 100 data points about somebody that might be important, and it's really hard to do. So what do we do as humans? We usually take 1 or 2 or 3 things that are important to us, and we filter it down to that, right? Oh, he's a self-starter. She's a leader. That I'll hire them because of that, But when you take all this data into consideration, how it all kind of comes together, it's too hard in our heads to get that together. When I have to figure their experience, their certifications, their references and GPA, do they have confidence? How well did they do in the interview? How good is their problem solving? What kind of job history they have, what salary requirements. When you take all this into consideration, could I make a better hire if I had a good model and good history of this? I would, because a human can't really sift through all this and make sense of it, right? So, and as humans, we ignore some of it and we take whatever's important to us. If I had a great GPA in college, I may think, oh, I'm going to hire people with a good GPA, right? Because that's important. I thought it was important, so it's important when I hire somebody. So those are the points I'm trying to make here. I'm going to go a little bit more into demos here. I'm going to talk about Azure Machine Learning, and machine learning services really is what I'm talking about here. So the things I'm going to do here is create a workspace or use a workspace in Azure Machine Learning Services. And the reason for doing this is it's not about building my model in Azure. In fact, I have multiple options about how I build my model. What I'm going to show today is I'm going to actually build it on my laptop, but interact with Azure so that you can see kind of how that works. There's actually several ways you can do that. You can actually work on your laptop, but build it in Azure. The reason for doing that is if you need the resources, right? Let's say building your model requires you to fire up a cluster of 8 servers and a lot of horsepower, right? And it's going to take an hour to run. Well, I don't want to do that on my laptop. I would provision that in Azure and run it there, even though I'm working on my laptop. But essentially what I want to do is, you'll kind of see it as I go. I'm gonna build a workspace. In that workspace, I'm going to have experiments. I'm going to run them. I'm going to track everything I'm doing in those experiments. Why? So other people can see it. So I can publish it to the world, right? They can see. I could show it to our executives and show them how we're doing and why we picked something, why we chose something over something else. And then I have a historical track of it. Then I'll also run it and then show what I can do when I run it, where I can track things, how I can do it. So it's providing a way for you to track what you're doing as a data scientist, to deploy it. I'll even talk about Docker containers and how to deploy it in a Docker container. So I did this session, or a shorter version of this session at SQL Saturday in Denver like a few weeks ago. And I think the Docker container thing kind of went like that over, like data scientists were going, well, why would I, I don't get that, right? And I can understand that, so I don't want to spend a lot of time on it. But the idea being that every program, every piece of software today, we're putting in a container, right? That's the direction. And the reason to do it is because it gives us a lot of power in the cloud. It gets scalability, it virtualizes it, right? It does a lot of things. So if I take your predictive model and put it in a container, I get all that power as well, right? And that's really what I want to do. I want to take something you did and deploy it in the cloud on 60 servers, right? A huge cluster that now I can use it any way I want. Or I want to deploy it together with an application, right? The application depends on it. It requires it to go live. As the application is deployed overall of the cluster, your model is also deployed throughout the cluster, right? So I won't spend a lot of time on it, but it's an important piece of being able to do it in Azure Machine Learning Services. So I'll get to the demos. Any questions? Any? Yeah.
So conceptually, I've got a problem where I have a lot of data. I have like 10 data points that I can work with because that's what the engineers decided to give me.
Oh.
Or I can go out and get logs, which has hundreds of data points, but I'll have fewer of those to deal with. What would you prefer in your experience? So like some of millions of data points, or a handful of them that has a lot more information?
I think that's too hard to answer. I think, without knowing the problem itself.
An IoT type environment where there's a whole bunch of other stuff that we could be tracking, but there's uploading what they can kind of manage right now.
Oh, okay. Yeah, I mean, I would say IoT generally, the data is not very rich. It's not very wide, right, if it's that type of data. But it depends. I mean, we do have a customer right now that's doing IoT type and making the data richer. But often the data in IoT is very repetitive or, not, if you're looking at it, it's not terribly interesting in that sense, right? So.
My question is more around where would you put your focus of attention, like trying to get more data into that, pump it over to that area where you're logging these data points, or trying to get the log information out?
Yeah, I'm always on the side of more data, I guess, right? But that's just, again, I think it's too hard to answer, like as a general question. If you want, we can talk afterwards. But yeah, maybe somebody else has some input, right? Yes.
Oh, so kind of relating to that, when you develop a predictive model using something like logistic regression or any kind of regression-based model, the more predictive variables you put into the model, the more likely you are to suffer from multilinearity.
Yeah.
How much of an issue is that if the model's predicting pretty well, are you concerned about multilinearity, or is it something you want to get improved?
Yeah, I don't know. I mean, a lot of statisticians don't like this. I've always kind of been on the side of, if the model's working, even if I've introduced something inside the data like that, right, or I haven't really accounted for it, but if it's working, all business cares about is that it works, right? If I can predict every time you walk in the door, if you're going to buy something, they don't really care, about how it's working under the covers, right? Now, it could be in the future you have, bad outputs, right? Because of that, or some bias, or that kind of thing. But kind of reminds me, I went to Adam Jorgensen's session yesterday. He did one on business, like one that was all afternoon, like back to back, right? So he did two, and it was good to get to a session that was just on business versus the technology side of it, especially since I'm on the business side, right? I have to go out and sell what we do and, that kind of thing. But one of the things, he had a lot of good points, but one of the things he didn't say is I wanted to raise my hand and say, in the business, nobody cares about the technology, right? We all care about the technology, and they don't, right? And as long as they're getting the results they want, and a lot of times people like us get in front of people and say, I'm going to tell them how great SQL Server is, right? Or I'm going to tell them how fast something is, and in the end, to me, that's my experience is if it's good enough for business, it's good enough. Now, some people don't work in business. Maybe they might work in military or other things, but most of what I do, that would fly in a business setting, right?
How do you manage your lifecycle deliverable? What kind of tools do you use, like DevOps and like source control that talked about earlier?
Yeah. I'm not going to go into source control much, except say that everything we're doing here should be in source control and should be. I mean, that's one of the things that data scientists should be kind of, if they're not migrated over to. This is how we work, right? We work in source control, we work in GitHub or whatever you're using, and that sort of thing. I'm not going to show that here, although the code I'm using is a Git repository, like my own, right, essentially. So, and I would work that way, right? I think anybody who's working in code and has different versions of code, right, or newer versions should be working that way, right? So I've got kind of two demos here. One demo is a little bit more of a copy of something Microsoft has on their website, and I'll talk about that and why I showed that, why I'm going to use that in a minute. But this demo here is one with data that I have that I've used in a lot of presentations over the years, and this is the one about predicting income. I have a lot of customer data, and I want to predict income. So what I'm not going to do is, if any of you guys were at my session last year, and I think one of the sessions I did last year was called Tips and Tricks with Python and SQL or something like that, right? And I showed in Python how to predict income. I went through the whole process, right, from beginning to end, bringing in the data, feature engineering, cleansing, analyzing it first, and then going into the process of building a model. I'm going to skip all that today and just build a model, right? So I'm not going to go through that detail because that's not what this session is really about. But I'm going to start with the file that's already like feature engineered, and that sort of thing. So what I'm going to do here, just to kind of talk through, I'm using Visual Studio Code here, right? And so you guys who work in Jupyter Notebooks, this kind of looks a lot like a Jupyter Notebook. So what I'm kind of liking about some of the new development environments is that I can open Visual Studio Code and make it look like a notebook, or I could write C# code, or I could develop an application, right? So I can do a lot of different things with it. The one thing I wanted to show before I go is extensions. You see that I've got these extensions loaded into my system. So you see that I'm using Anaconda, the Anaconda extension pack. I'm using the Azure Machine Learning extension, which you need to do, right, to do what I'm going to do. You don't need the C# one, the D3 one. That's for other projects we're working on, so they just happen to be there. But and then the Azure account one helps because it helps you connect with your Azure subscription, right, as you're working. So what I'm going to do is run this first piece of code, and basically what this is going to do is connect to Azure in my account, and it's going to create a workspace for me. And this workspace is where I'm going to do everything. So the workspace is, you see my subscription ID there, that's the one I use for these demos and that sort of thing. You see that I call it Databricks Workspace, or the resource group. This has nothing to do with Databricks, right? This is just one I'm reusing that we've used for other things, right? So somebody called it Databricks Workspace when we first were doing some things. But my workspace name is Testing Azure ML and the region. And so essentially now everything I'm working on, I'm going to do within that workspace. So what I'm going to do is I'm going to import all these libraries because I'm going to need them to train the model that I want. And essentially what I'm doing is I'm going to use k-nearest neighbor algorithm to predict income. The reason I want to use that one, I think it's one of the easiest ones to follow and understand. So if you're not a data scientist or if you're new to this, I think it's pretty easy to see what we're doing when we use that algorithm. So I imported all those libraries. And now what I'm going to do is this. And this is kind of out of order. I normally probably wouldn't do it this way. But I've got a function here that's going to classify income into, 5 categories I think I have. So basically, if your income is less than $18,871, I'm going to say you're in poverty, and then up the next level above that, lower middle class, up to $47,000, and then middle class. I'm not sure that's a real word, but middle class, up to $113,000, and so on. And the reason I'm showing this here is because if I do this as a data scientist, how do I know, or how does another data scientist know I did this? And what I want to do is log this. I'm going to log the fact that I did this into Azure Machine Learning Services. So when I run this, it's going to create this function, which really, it's not doing anything yet because nobody's calling the function yet. The next step, it's going to create an experiment in my workspace in Azure, and I'm going to call it Demo 2, since I already have a Demo 1. I'm going to run that. I'm going to create a run object from that experiment, then I'm going to log to that experiment. So this is the first time I'm connecting. I'm actually interacting with Azure and storing something there. So let's go back there and see what I have. Does this show okay on this screen? It's okay, huh? If it's too small, let me know, or I can zoom in. So I should have an experiment here. Now, I'm in Azure Machine Learning Services in my account, and you see that I have Past Summit Demo 2. I just created it, right? Didn't have it before I went there. I'm going to click on that, and you're going to see some information there about that experiment. It says it's running, and that's about it, right? There's not much other data you see here. There's this little chart over here. So let's open that up. And you see these metrics that I have here? That came from my code, right? As part of this experiment, I stored that with my code. Now, I could call it whatever I want, and the way I labeled it here, I could label it however I want. But I put them out there. Why? Now it's available to everybody else, right? When somebody goes and looks at this model, they know when somebody tells you, hey, I'm going to tell you whether they're in poverty, well, what does that mean, right? Does that mean you don't make any money? Does that mean you're bankrupt? Well, you can see here it means your income's $18,871 or less, right? And so somebody else in your organization using it will know, right? So that's a lot of what this is about, right? Making this available to everybody else and being visible that way. So the next thing I'm going to do is read this file. And this file is essentially this file. This is the file that I said was already feature engineered, essentially. You see that I have income over here on the left. I have a lot of stuff about people, right? Number of children they have, children at home, do they own a home? And their bill, how many days are they overdue on average? How many times have they been overdue? How much do they owe me every month? What's their education like? What's their occupation? What bank do they use? What credit card they use? And so on. So when you look it up here at my columns, right, a credit card, for example, you see that the credit card type is MasterCard, and it's either a 0 or a 1, right? You either use a MasterCard or you don't, right? The next one is Visa. You either use a Visa or you don't. So that whole feature engineering aspect of it is done. And even the type of service you have and that sort of thing. So I know a lot about my customers, and I'm going to build this model with this code. So it's going to read that data. It's going to label the columns and create a training and testing data set, I guess. So I guess just to cover that part of it, this is kind of a data scientist kind of the way they would work, right? They have a lot of data. They're going to split it up into training and testing. So they train the model with one set of data. They would test it with another set of data so that the model's not trained with the data that it's being tested with. So I'm going to do that, and you'll see at the end of this how many rows I have in my training data set and my testing. So essentially 14,000 rows. You see it here, right? In this area, right? 14,016 rows are in my training data set, 4,672 in my testing data set. Next part is I'm going to use the k-nearest neighbor algorithm to apply to that data and give me some output about it and show the confusion matrix and classification report. So this shows me how well I did, right? How well my algorithm's looking. And so you see the confusion matrix here. I just spit it out. I didn't actually label it. So you see that all I'm getting is what I should be getting there is poverty on the first row and at the top on the first column and saying, hey, 482 times you predicted poverty, they were actually in poverty. But 120 times you predicted poverty, they were actually lower middle class, right? And so on. So it tells me how I'm predicting and what they really are and how many times I'm correct. The report below is a summary of that, right? So it's basically telling me there's precision and recall. There's two different ways to see how well I'm doing. And then the F1 score is kind of a combination of those two. It kind of uses both of those to tell me how well I'm doing. And you see that I'm doing pretty well in predicting, especially in predicting middle class. I'm doing it 90% of the time, right? I'm only predicting poverty if you kind of combine both of those 83% of the time, and upper middle income 81% of the time. And I actually don't have anybody in upper income. The data set dropped those people out or just didn't have anybody there. So there's nobody there. But kind of tells you a little bit about my results. So what do I want to do with this? Same thing, right? I want to save this. I want to show that this is where I got to after a lot of work, right? I mean, I'm skipping all these steps here, gathering the data, feature engineering, and getting to this step. Maybe it was weeks worth of work, months worth of work. I've got results that I like. I want to put them out there, right? So this next piece of code will do that. So when I go back to Azure Machine Learning Services again, I'm going to refresh here. And hopefully I'll get a result here that will be valuable to us. Yeah, and you see here, I didn't format it or anything, but you see that I've got a confusion matrix in here. And that confusion matrix is the data that I showed you in that table, right? So again, I'm saving it off into Azure and keeping it as part of my experiment to show these are the results of my experiment. This is what I'm getting as a result. Next thing I'm going to do is I'm going to do something that needs to be done because I need to create a file out of this model that I'm working with so I can do more stuff with it. And then this last run command just basically shows you where in Azure it is. Like if I didn't know where in Azure it was, I could hit this link and it should take me to where I am in Azure and where that model is. So those are just mechanics of how this works. But let's go to the next step. So here's what I want to do, right? When I did the k-nearest neighbor algorithm, what did it do? It basically plotted a multi-dimensional point in multi-dimensional space and said, how far away am I from other customers? Who are the customers I'm most similar to, right? And so how many customers did it compare me to? Does anybody know the k-nearest neighbor algorithm well enough to know how many it would have if I didn't say how many? No, 5, right? Basically, it said, I'm going to compare you to 5, and the 5 that you're closest to are the ones I'm going to say you're alike, right? So if they're in poverty, that means you're going to be in poverty, right? Or that kind of thing. That's what it's essentially trying to do. So is 5 the right number? I don't know, right? It probably isn't. But how many should I compare you to? Well, the next thing is that the next piece of code is an example of I'm gonna compare you to 1, then I'm going to compare you to 2, then to 3, then to 4, and see which one I get better results with. Right? So what I'm going to do here is run this and loop through the k-nearest neighbor algorithm and see where I'm getting the best results. Now, what's happening here is 2 things. You're going to see a little plot on my screen that shows you something about the data. But I'm also saving this off to Azure, right? As I'm picking the best number, I will be able to see it in Azure and maintain it there as well. So as it loops through, in fact, I probably have data over there already. This is a little slower because it's actually looping. Let me go back and refresh this here. Yeah, you see these run numbers I've got in here? Those are the loops as I'm running it. And you see that another one just came in and another one came in. It tracks how long did it take to run. It tracks other data about it. So if I go into one of these, we'll get some information about it. And basically what it's telling me here is that if I compare you to only one other person, I'm going to be right 82.8% of the time. Well, if I'm classifying you in poverty, remember this data is fake, by the way, so this, it's probably not going to be that good. But so if let's say the person I'm the closest to is this gentleman in the front in the green, and he's rich, they're going to think I'm rich, right? Or if he's in poverty, they're going to think I'm in poverty, okay? So again, I'm saving the results of the experiment and showing you, and it's tracking it for me. You see how it's actually building a little chart out of my run number and all that here. As I go along, though, here I compared you to 14 people. Let's see how that did. And you see that I get better results, right? I'm better. My score now is 86% or closer to 86%. So I'm getting better results if I did it that way. So it's almost done. I think I did it a total of 20 in this case. And let's wait for it to finish because what I really want to do is this. I want to add a chart. And what I want on that chart is, let's see, score to be across on the left-hand side, duration not to be there at all, and K to be down the bottom. Oh, it's already there, actually, run number. So you see this chart shows me how well my model's doing, right? And this is what's pretty cool about it is that you see here that when did I miss one here? If I put this down there, will it work? Nah. I think I messed it up. But so you see here when I get to about 4, I'm hitting 86%. As I go further, I'm actually getting a little bit worse. And then I get a little bit better. So as I get to about 13 or 12, I'm at a little bit over 86% again. and then I go down. So what's this telling me? Well, first of all, if there's in the data set that I have, if I compare you to maybe 4 neighbors, I'm going to get a pretty good result. I don't really need to compare you to many more. 14 is probably the most, or 12 I think is, 12 is the most I should compare you to. Why wouldn't I compare you to more? Well, that uses a lot of resources, right? There's a lot of processing power here that I don't want to waste, and I want my results like that. If I had millions and millions of rows in this data set, how many people could I compare you to? 100,000? 80,000, 10,000, you know? So when I find that optimal number, I want to stop and say, I'm not getting better results by comparing you to more. But the cool thing about this is I've got a chart here now that I could show. I can save it. It's part of this experiment. It's already saved. It's not going away. We can go back and look at it and say which experiment gave us the best one, or why was that one different? You know, what was good about it? And we're tracking everything. Yes?
When we get that sample set of data, that 14 might have represented 14, or the initial 4 might have represented the complete data set we have.
That's right.
But maybe when we move further to maybe 100,
Yeah.
it may not be representing the big picture.
That's right.
So how do we select?
Well,
that number?
so that's the fine-tuning and refactoring of this, right? As that data comes in, I'm going to run this again, and am I still at the optimal number? And if I'm not, do I need to move it? Do I need to do something with it, right? As my data grows, conditions change, right? New data comes in, right? Conditions change. And new data may not be collected the same way, or I may find another optimal number, right? But again, this is a very small example. What I'm trying to show here too is the balance of resources. But you know, as a data scientist, if somebody comes to me 6 months later and says, "Well, why did you choose 4?" You know, well, here it is, right? It's saved, it's stored, and that was the version we wanted. In fact, there's code in here that'll go through every version I ran and pick the best one and say that's the one I'm going to deploy, right? And so then that's how you know you got the best one, right? Based on that criteria. Yes. This is a demo, right? So it's easy. If I were to choose I chose 20 iterations just to show how it goes out. In real life, I probably wouldn't do it that way, and I wouldn't start at 1. I would probably never compare it to only one other person in the data set, right? I think it depends how unique and distinct each row in the data set is, or each observation is, right? The more unique it is, probably, you know, it makes it more difficult, right, to determine. But I wouldn't say that. I wouldn't say there's a rule of thumb. You'd probably do statistical analysis first to tell you what that is. Like in this case, I also do 20 because it takes too long to run everything else, right? If I'm comparing you to 100 or 1,000 other people, then 1,001, then 1,002, it's going to take too long, right? So it's just a demo. But you see here that I have it here, and here's my chart, right? The chart I created, and it kind of shows me what I should choose. And really, if I'm trying to find the optimal score here, I'm going to choose 12. That's the number that was the best, right? So let's go on to the next step here. And you see here in Python, I could plot it, and I get essentially the same plot, right? I get the same chart, or you know, you see here that 4, is that 4? I don't know. I may have plotted this 1 over. I think in Azure, I moved it over 1, but you kind of see the same pattern, right? Then if I run this, it says experiment. It tells me where that experiment is again, so I can find it in Azure. That's essentially what the name of it is, what the link is, that sort of thing. So I'm going to stop there with that one, right? Because we were able to select the best model just kind of by looking at it, right? And not doing much more than that. I'm going to switch to another demo. This is the demo that I said is mostly something that you can go to GitHub and get from the Microsoft repository, but I've obviously customized it quite a bit to make it work for what I want it to do here. But what it's going to do is going to show me 2 additional things. One is once I run all those experiments, it's going to go find the best one and pick it and say, this is the one you should be using. And then the second thing it's going to do is deploy it. And the way this is going to work is it's going to be automatic, right? I'm not going to visualize it and go, oh, that was the best one. It's going to choose the best one and say that's the one people are going to use in production. And it's going to deploy it as a Docker container, so then I can call it as a web service, right? So what I'm going to do with this demo, because if I ran it, again, step by step, it'd probably take a little long. I'm going to let it run and kind of talk as I go, because it's probably going to run for about 2, 3, 4 minutes, and I can talk through it a little bit. But this demo is, this is data I don't really understand very well, actually. It's data that comes inside, I think it's in one of the Python libraries, in sklearn, I think, or one of them. It's a diabetes data set. So if you guys have messed around with those, you probably used it. But basically, it's a lot of numbers, and it's trying to predict another number, right? And essentially, I think it's your chances of getting diabetes based on these other numbers. But the other numbers, they've been feature engineered and normalized, and a lot of stuff has been done to them. So I haven't really gone into the details of how that's done. I didn't want to say anything, but my voice is held out. I'm surprised. So I'm going to do the same thing here. Is I'm going to create a workspace, and let me talk through it a little bit. And then I'm going to separate the data, the diabetes data, into training and testing. I'm going to create an experiment. In this experiment, a ridge regression model is the one being built and used. The nice thing about it, from a demo point of view, there's an advantage to it, is that I can determine the mean squared error of all my output, right? So I can test all my data and then say, hey, this is the mean squared error of that data set, or of that run, right? And then I can store that. So it makes it easy. For every run, I have one number that I output. When I go back and look and say which one was the best mean squared error wins, right? That's the one I'll choose. Other models obviously would be more complicated to determine which is the winner, right, and which is the best one. So what I'll do then is show you how it loops and finds. You'll see it looping and trying to find the best one. And then it'll deploy it. And deploying is actually not terribly fast, actually. It takes a little bit of time and to do it. And then we'll use it as a web service. So at the bottom here, let's see, right here, let me scroll down a little bit more. This is the part number 13 here, cell number 13. That's the part where it's going to deploy it. That's a little slow, right? That'll take a little bit of time to do. And then the cell below that is where we're going to call it. And you'll see what we'll do is we'll call it as we're going to call it as a web service, essentially. What I'm going to do there is I'm taking, let me zoom in on that one too. What I'm doing is I'm going to take the first row in the data set, in the test data set, and use that as an example of how I can call it as a web service and get a result right back. So before I do this, let me ask you this. For data scientists in the room, is this all like very foreign to you? Is this something, are you guys doing it or thinking about it or anything like that? Is it like way out there still? Databricks, okay, yeah. Yeah. Yeah.
So you're showing Python.
Yeah.
The presumption is you got, correct?
You could, yeah.
The same way it would be
Yeah, that would, yeah.
Okay.
Yeah. In fact, that's a good point here, like about working in Visual Studio Code, right? I could code in a lot of different environments or different languages. That's one of the huge advantages I like about Databricks, right? Is Databricks, I can actually code in multiple languages at the same time if I want to. And a lot of the tools, I think, are going in that direction, where it isn't like you have to do it in a certain environment. By the way, before I go on, here's one point I wanted to make, right? I have the Azure Ml Sdk that you see down here at the bottom, right? Loaded, right? Let's see. Let me get rid of that because it's hiding it, right? Okay. And so it's using the Azure Ml Sdk 1.0.45, and then I'm using Python 3.7.3, 64-bit, and the Conda distribution. Now, if you look at what I've actually got installed here, I've got all these different versions of Python installed. This is actually the only one I could get this to work in. So just so you know, and every other way I tried it, something failed, right? Something didn't work. So if you're going to do it, use Python 3.73, 64-bit. Yes?
So you're using ML services, but do you see in production where people are using the studio, the UI drop and drag?
No. I don't have any customers or anybody who's used that as a production tool, I would say. I mean, I think it demos well, and I think it gets them to understand it, kind of.
Would you use that as like a proof of concept to get
Yeah.
the customer
Yeah.
to see the value of?
Yeah, like you want to show executives what you can do, how the process works, and it kind of flows through, you know, that tool, right? Shows how the data comes together, how it gets crunched, you know, and the output of it. You can create a web service, right? All that. I think that part of it is worthwhile in that sense, but I don't know of anybody who, and you know, and I talk to a lot, in consulting, right? You talk to a lot of customers. Nobody's actually using that tool as their development tool that I know of. And I've talked to other people, and I've never heard of anybody using it that way. Microsoft might not tell you that, but, you know.
Do you know why no one is using Studio as a machine learning tool?
I don't know. I mean, I think a lot of data scientists are coming out of like boot camps or like graduate programs. That's not the way you're doing it, right? You know, somebody told me they were at General Assembly, right? Or, maybe it was the guy, it was the usher outside, or the guy watching the door outside, actually. And, you know, if you're at General Assembly, they're teaching you coding Python, coding, you know, that kind of thing. I think, you know, to use a tool like that, you already have to be an Azure customer. You already, you know, you wouldn't go to it if you weren't, right? And I think those types of tools, right, in organizations like universities and boot camps just don't get used, right? You know, they don't teach that way. But
But for a
Yeah.
regular SIS or SSRS developer who is trying to move to
Yeah.
data science field,
yeah.
this sounds pretty familiar.
Yeah. I mean, there's value right there, right? It's familiar. It works like a lot of other things in the Microsoft world, right? That kind of thing. So, but we have some really good data scientists, and they hate to drag and drop, and you know, oh man, I don't ever want to do that, right? That's like a bad data scientist, right? Is in their minds, right? So I'm going to start this running, and what I'm going to do here is I'm going to actually run the whole thing. I'm not going to stop at each cell. Hopefully it will run. Yeah, and by the way, it's a little bit of a miracle that I didn't fail on the other demo, because it fails on something half the time. The hard part about this is maintaining that connection to Azure and making sure it doesn't drop at any point, or you're always logged in. If it logs you off, then you lose that, right? So it's a little bit of a pain. I wonder if this one is actually failing here. Let's see. Oh, by the way, there's this other preview that kind of shows what I was showing that they've put out there. Similar thing, right? That I can use, but it's just a different UI, right? That they've created. You see all the different runs, things like that here, right? As well. So is this failing then? Let's see. Doesn't look like it's moving very much. Oh no, it is actually. I think it is. There we are. We're actually on we should be on cell number 5. Yeah, okay, good. It is moving. It's hard to tell sometimes. So if you look at this piece of code, this is the piece of code. It's doing the looping and building the model, in this case, 10 different times. And what it's doing here is ridge regression uses an alpha value. Every time it's changing the alpha value by 0.1%. I'm trying to see where do I get the best results. You see here at the bottom, it says 70% right now, and it's going to go to 80 in a minute. That's each loop, right? It's each time in the loop, it's built the model, it's put the results out in Azure, and it's tracking how long it takes and that sort of thing. So it's almost done. I think it's on the last run. Now it's done. So I should be able to. Now it's going to do other stuff. So I'll go back to the code. This code will continue running, but I'll go back to Azure, and then we should be able to see that as well in our data here. Yeah, I don't remember if that, I think that one was running on Past Summit Demo 1, not 2. Let me go back. No, not sure that was right either. Let me go back and check. By the way, this code here was an example of the model just running once and not interacting with Azure, but showing me that the mean squared error for that run was 3,424 in that case, just outputting it to me in that case. Oh, I called it. Okay, I think I've got it. It's this one here. Is it? Yeah, I think it's that one. So now the bad thing about this is you see I've actually run this a lot before, right? So, and you see that what I'm getting out of a run number, I'm on run number 68 now, right, is I'm getting the output here. And I'm getting that if my alpha value was 0.9, my mean squared error was 3,359. So what the code's doing right now is it's going through all my runs and saying which was the best one. And then in this case, it's a simple choice of choosing the best mean squared error. So if I go back to the code, well, by the way, while that code's running, I wanted to show you guys this too, now that I think about it. This is on the Microsoft side on Azure. This is the data science lifecycle, right? So they're talking about it in kind of a similar way like I've been talking about it. And just so you know, by the way, I think the tools obviously still need some development, right? They still need to mature. But essentially, they're also talking about it on their website, right, as to how that should work. So let's go back here. Let's see where we are. So what it does to pick the best model is this is the loop where it chose the best one, and again chose it on a simple mean squared error for the whole data set. And it tells you down here, because I put it down here, right, is the best run, and it has a key there, right? And it says it's when the alpha value is 0.4, because I got a mean squared error of 3,295. So that was the best run. So it's going to label that one as the best one, or tag it. Then it's going to deploy it. And to deploy it, it has to register it. This is where you need a little bit of the software engineering side of things. It's going to register it. It's gonna let me go down here to it's gonna pull up the environment, create an image in the environment. Am I past that step yet? I am. And you see there's a lot of code here. It's still code heavy in this case, right? So here's where it's deploying it. And in this code, the reason I know it's deploying it because we haven't finished this piece of the code yet. You see that it says creating image. It's running, succeeded, image creation, operation finish, right? And now it's waiting, right? It's waiting to come back from that. And this is what's happening here for you guys who are data scientists, not software engineers, right? It's taking your code, just like if I had written an application or a website, taking that code, putting it in a Docker container, deploying it, meaning now what I can do is take that and deploy it anywhere. I can deploy it on servers, I can deploy it on other machines, I can deploy it widely throughout my organization, multiple, on a big cluster, right? And it'll be used. So you see there it's finished deploying. Now I'm going to test it. So this piece of code here, and I'll run it again, is essentially, let me move in on that. It's essentially saying I'm going to use a web service, and the web service is called Past Summit ACI-SVC. I'm going to take the first row in my test data set. I'm going to pass it to that web service, and I'm going to get a result. So the first one I pass in, I'm going to run this again, and I get a result, 217.67. right? That's what I was saying about earlier about making it into a function that's now useful to anybody in your organization, right? By running this code, I'm able to deploy it. Now, anybody who can call this web service can access can access all the great work I did, right? Essentially, so yes. Well, I think that's the idea behind saving it in Azure, right, as opposed to saving it in the code. The notebook's really good for notes, right? Notes, right? As I'm running, I'm tracking what I'm doing. I probably wouldn't say, you could, right? You could save the output. Like right there where I said the best model was where the alpha value was 0.4. That's in the notebook. You could save that. And you can save that and check it into GitHub. Mm-hmm. Right. Oh, yeah. I don't know. I mean, I think in a case like this, right, where I'm mixing data and code together, right, where in a lot of applications I don't, right? It's about the code. It's independent of the data. I think that's one of the reasons for a lot of what I'm doing here is the data is being saved, right? The data's out there and it should exist forever. Because I'm also putting a version on that data, right? It's versioning it, the code's being versioned. I should be able to go back and find everything I need if I want. So, yeah. And you see here what I was able to do down here is pass it the whole test data set and have it come back, right? It actually is printed. It's in this plot down here, so I won't look at it too much since we're almost done. But you see here that this is an example of what the data looks like and the URL or the URI. This piece here, oops. So this is the URI right here, right, that I need to call. And then the data below that in JSON format is the data I would pass in so that I would get my result back, right, essentially. So that shows that. So essentially now if I go out to Azure, I should have one more, I should be able to see all this and look at deployments. Should be able to see that it's deployed. And yeah, it's right here, I guess. And it shows you the same thing here, right? Here's the URI that I can use. I deployed it as a Docker container where you specify CPU and memory. So it says, hey, it's going to run on 1 CPU and 1 gigabyte of memory. That's what I want you to allocate for it, right? But essentially, that's where it is, and it's accessible in that sense. And this is how you would go back and find how to access it, right, essentially. You see here that I chose the best model. I tagged it. It was version number 8, right? So it keeps a version of it and tells me some information about it, right? If I was doing this better, I would tag it better, describe it better, that sort of thing. But essentially, that's what it is. So that's essentially it, right? I think a lot of this is still in its infancy, right? It still needs to be developed more. It still needs to be more mature. But I think that's the direction things are going. And I think, in general, if you had to do this before, you were going to roll your own, right? Essentially, well, how do you put your algorithm in a Docker container, right? And now you have some tools you can do that. How do you create it into a web service? So, but essentially, that's what this session is about, is being able to do all this. Yes? Say that again? Well, in this case, it isn't because I put a wrapper around it, right? But I could have deployed it in different ways, or, I could have it scale out in different ways, right? Or put a bigger number around it, right? I don't know if that is yet. I think, yeah. Yeah, and actually the reason I chose 1 CPU and 1 gig because it's the cheapest, right? So it's going to cost me the least amount of money in this case. In real life, I might have chosen something different. So, any other questions? No? Well, I really, oh, one more. Let's take one more question.
Make model, train it, deploy it. How do I make the results actionable? And the example which you gave, I come from a healthcare background. I work in a hospital. So the diabetes
Yeah.
example what you gave, is
So, yeah.
every single patient who comes into the hospital, which has 40 years of
Right.
age, I want to pass through model and try to protect them.
Yeah, so I would put that into code. When I call the web service, I get a result. I'm going to track that result somewhere where later on I compare it to the actual result. I wouldn't do that in Azure because I'm doing that 10,000 times a minute, or I'm doing it a lot. And I've got a lot of data that I will get a real result later from, right? I will get an actual. How do I track the actual versus the prediction? So I would do that in code, not here. Right, in the application. Well, thank you very much for coming, everyone. Thanks for staying till 6.